Hello again, Algebra 2 students. We are back into our complex numbers syllabus, and we are on Tier 2, Lesson 2, simplifying radicals using I. We're going to check off our booklet. Here we are in Lesson 2. We want to remember from Lesson 1 that we can break apart radicals like this and get our -1 square root, which gives us our I. And I want to alert you guys to some common misconceptions here. The first one is when there's a negative outside is not the same as a negative inside, because if we simplified this one over here, we would do the radical first, which the square root of 64 is just 8, and then it would have a negative in front, and that does not equal what we would do over here. We would break this apart and have our -1 square root times our regular 64, and then this would give us an 8 here, and this would give us an I here. And we know we would write that as 8i, and 8i and -8 do not equal each other, so these are not equivalent. And then the other thing you want to remember, your PEMDAS rules. So you do parentheses first, then exponents, then multiplication, division, addition, and subtraction. So we do what's inside first. So to do this problem, we would break this apart inside first. So we would have the square root of -1 times the square root of 5, and then square. Simplify the inside of the parentheses to be I times the square root of 5 squared. And now we would use exponent rules from Algebra 1, and we would apply this square to both things in the parentheses. So we would get I squared times the square root of 5 squared. And that would give us -1, because I squared is -1, times 5, which gives us -5, which does not equal 5. Let's use some of this stuff up here to simplify these following quadratic expressions. So again, we want to break this apart to the square root of -1 times the square root of 25. Well, the square root of -1 is just I times the square root of 25, which is 5. And again, we don't write it as I5, we would write it as 5I. And that's our solution for that one. And then we would have -1 square root times the square root of 28. Well, the square root of 28 is a decimal, so I'm just going to break it down into prime factorization. But first, before I do that, I know that this one's going to be I times something. So I'm going to do 2 and 14, and then 14 goes into 2 and 7. And then my pairs, I have 2 pairs of 2, so I get I times 2 squared square root times the square root of 7. The square root and the square on this 2 cancel, so that gives me I times 2 times the square root of 7. And to clean it up and write it in correct fashion, the 2 goes before the I, so I would have 2I square root of 7, and that would be my solution to this one. Here, again, break my square root up to -1 times the square root of 8. I would prime factor this into 2 and then 4 and then into 2 more 2's. And then I would have my pair here. So I would have 3 times the square root of -1 times the square root of 2 squared times the square root of 2. And I would simplify this all down to 3 times I times 2 times the square root of 2. And then now I can simplify what's outside the radical. And remember, the I comes after the real numbers. So 2 times 3, using the associative property, 2 times 3 is 6, times I times the square root of 2 would be my solution for this one. So for this last one, I'm going to need 2 solutions. So I'm actually going to erase some of what we've already done. I hope you got that all written down. You could have paused the video if you needed to, so that I have room to do this last one here. Because now I'm going to have 2 plus the square root of -12 and 2 minus the square root of -12. Well, I got to break this up again, the radical. So I'm going to have 2 plus the square root of -1 times the square root of 12. And then I need to prime factor this. 2 and 6. And 6 goes 2 and 3. So here's my pairs. So I get 2 plus the square root of -1 times the square root of 2 squared times the square root of 3. Simplifying this, I get 2 plus I times 2, because 2 squared, square root of that is 2, times the square root of 3. And if I want to simplify this, remember the 2 goes in front of the I. But this is addition, it's not multiplication, so that just has to chill out in front. So I get 2 plus 2i square root of 3, and that is the solution on that one. And we're doing this because this is commonly how you get a quadratic solution out of the quadratic formula. So that's why I'm choosing to do this. Again, I want to go 2 minus the square root of negative 1 times the square root of 12. Well, I know that the square root of 12 from the work over here simplifies down, so I have 2 minus the square root of negative 1 times the square root of 2 squared times the square root of 3. I don't have to do the prime factorization again because I already did it. I already did it right here for 12. So now I just want to simplify this. I get 2 minus I times, because 2 squared square root is 2 times the square root of 3. Again, this is a subtraction here, so I can't add that into the multiplication, so that's just going to stay out in front. 2 minus 2i, because remember the real number goes in front of the I, times the square root of 3. And that is my two solutions to that one.